Hello, hello. Hello. All right. I think finally only 30 minutes late. I'm so sorry about that. Definitely a bit of a busy day, but we're here. We're making it work. How's everyone been? It's good. So yeah, I guess I'll go ahead and get started. I have no idea how to turn that projector on, and the one or two times that we have used it, it's just not really worked. So hopefully that will suffice for today. Just the TV behind me. So yeah, I guess to get us started, my name is Cameron. I'm the co-president of natHACKS, and today we'll be going over some really introductory stuff to kind of get started on Python and all the different bits and bobs you need to know to start learning how to program, or possibly if you already know how to program, kind of like different pieces for how to transition over to using Python if you know other languages. So I'll go ahead and I guess go over the quick table of contents. So this is a decent bit of content that we've kind of compressed into the single workshop here. We'll probably breeze through like a lot of it pretty quick, just to provide kind of like make sure that we're covering everything, but just not stick around on some of the points for too long. If you do have any questions, like please let me know. Just kind of shout it out, and I'm glad to dig in more and clear up any kind of misunderstandings as we're going. So today we'll be going through data types, the basic operations in Python, arrays and dictionaries. We'll be coming up to that. And then for the second half of this, we'll talk about functions, conditional logic, and loops. So with all of these different concepts, really that's the majority of what you need to know to just be able to make different programs in Python. There is one more thing that is useful to know, and that's like libraries, but we'll be covering that in a lot more depth in the advanced portion of this workshop later this week. Is it later this week? It's in the future. So that being said, we can go ahead and open our Colab notebook. The rest of this workshop won't actually be on slides. We'll be going through and doing actual coding examples. And with Colab, it's short for Google Collaboratory. It's essentially like this online coding platform, so we can code along together. So if you go over to your web browser and type in, that's not my web browser. If you go over to your web browser and type in nathacks.ca/ws0, that should take you to the correct place. Huzzah. And I'll just leave this link up for a little bit longer. I guess let me know. I guess give me a thumbs up when you're there. Awesome. Good to go? All right. So we can transition over to the workshops now. So yeah, this is a little bit redundant. Table of contents, we'll be going over all these things. This is basically the table of contents in the other one, but with like slightly more information. So with that, I guess we can just jump right into it. So first up, we have data types. So within your programming language, you are going to be, well, I guess where should I start? Python is a dynamically typed language. And what that means is not super relevant for like first starting out, but I mention this in case you're switching over from a different programming language. What dynamically typed means is the language itself tries to be smart about what data type you're giving it. So here, for example, we're giving it a number, and the program, Python, is going to interpret sort of different data types differently, I suppose. So if you give it a number, it will infer that it's a number. And if you give it a floating point number, it will infer that it's a floating point number. And I guess I'll go ahead and dig into what exactly those two things mean now. So I guess that's a little bit if you're transitioning from a programming language. So integers, or ints, are any whole number, positive or negative. So we have a couple examples here. We can define x as 1, 69, negative 43, 10. All of these are valid integers, and they're stored as such. So if you go ahead and run the code block, you can press the little play button in the corner there, or you can press Shift Enter, and it'll run it. It'll probably give you this warning. I'm not Google, so it'll complain that, you know, be careful who you trust, I suppose. But I'll be walking through exactly what the code does. So hopefully that shouldn't be too worrying. So yeah. So what we have, if we go ahead and run this code block, we're not going to see any output. We just haven't asked for any output. We've defined a program that just defines stuff and then carries on. One thing we can do to get output and kind of check and verify what we have going on is we can use the type function. We'll come to this later in the workshop, but what type does, if you type it out type and some round brackets, we can put in any one of these variables. So I can say type y, for example, and then if we go ahead and run this with Shift Enter, it will take a second, and then it'll let us know that the variable y it's an integer. So hooray, I'm not wrong so far. What we can do is carry on to the floating point numbers. Floats are like integers, but they hold everything after the decimal as well. They have some amount of accuracy. More often than not, it's more accuracy than you're ever going to need. So you can define it like that. And once again, we can ask for the type of it by just saying type y, and it'll say we have a float. The other data type that you're going to be interfacing with a lot is the strings. So strings are just words, just a collection of characters, numbers, special characters. Anything kind of flies in a string. You can have Unicode as well, but be careful with that because it may not render the way you want it to. Anyway, strings are just words, so we can define a string like hey, and if we run it, it'll give us hey back. What I'm doing here is just using print. Essentially, it takes whatever your variable is and it puts it in the console for you to see. So yeah, that's kind of like the data types that you're going to be working with the most. You might notice, yeah, they're initialized in the same way. That's just Python being dynamically typed. In a lot of other coding languages, what you would have to do when you're defining a variable is say like what type of variable you want that to be, how you want the program to interface with it later on. So for example, if I was in C++, I'd need to say like y is a string, but Python is smart about that. As well, you might notice we've sort of taken these variables and we've used them multiple times in the same compiler. And that's because Python lets us dynamically associate or allocate, or we can write a new value to a variable and we can change its data type whenever we want. So here in the single code block, what I'll do is I'll start by saying x is a variable that represents hello. I'll ask for the type and print it out. And then in the same code block, the same execution, I'll then change x to be an integer. I'll say 1, I'll ask for its type and print x. And if we go run through this, it allows us to do both of those things with the exact same variable. We can change it. Usually you don't want to be doing this. You want to avoid this. But if you ever run into problems where it's like, hey, what's going on? Why is this a different data type? You are allowed to change it, and Python's not going to complain or anything. That was hopefully a really painfully slow to get through introduction. But I guess, do we have any questions before we jump over to the next bit? No, awesome. So I'll probably talk about basic operations a little. I don't think we need to get too in depth. This is essentially just math, plus, minus, multiply, divide. You can take your numbers and do the meaningful stuff with it, I suppose. So you can define two variables, 1 and 2, and you can say like z is equal to x plus y. And if you run this, z will be 3. Pretty straightforward stuff. We can get into some slightly less trivial stuff when we do something like this. So pop quiz for everyone. If I run this code block, what do we think will be outputted to the terminal? It will be 8, I hope. Oh, that's the wrong computer. Yes, it's 8. So unlike your math where you'd be like, you know, if you write out x equals x plus 1 on like your math assignment, people are going to be confused because x is not equal to x plus 1. Those are two different things. But equals in Python at least is assignment. So we're essentially just taking x plus 1, which is 8, and saying the value of x is going to become whatever this output is. So if we run that, we get 8. In fact, this is something that you're going to see a lot when you're trying to program, especially if you're working with like loops, for example. This is pretty common, so there's a shortcut for it. If you just say x plus equals, it will just increment x by whatever amount you add to it. Floats work the same. You can do all of your operations with it, and you get whatever different value you want. Strings, Python tries to be smart about strings as well. You can have all of your different values, and you can use your plus operator. It doesn't make sense to try and mathematically add different words together, but Python does the next sort of rational thing, and it just concatenates them. So, you know, if you print out 3 of these different things, it'll combine them together. Small problem with this string is that we're just combining these strings and we're not putting spaces. So, you know, you can add in these spaces and have your string print out in a much more readable way. Just a hope. And then, yeah, another thing you can do, you can't divide or subtract strings. That just doesn't make sense, but Python is one of those languages that will actually let you do string multiplication. So this also does the intuitive thing. It just says, like, if you multiply a string, so my by 5, then it'll just print it out 5 times. It's kind of goofy. I've never actually used this, but fun fact, I suppose. Arrays. So an array is also a data type, just as much as any other variable. As an integer, string, it's just something that you can store information in. So we can define an array by just using square brackets. So you can define an empty array that just won't hold anything in it. That's a pretty useful thing to do because then you can have this variable that you can keep adding stuff to. String arrays themselves basically just hold different data types. You can think of it kind of like this little box that you can put stuff in. So we have these 3 strings, and we can add them into something that we're calling string array. And if we have that, Python, it allows you to store multiple different data types in your same array. It's not super good practice because usually you're going to be iterating through an array and doing like the same thing to every entry of it, but you are allowed to do this, it won't complain. And you can even store arrays inside of arrays. You can go pretty much as deep as you want, but usually you don't want to go forever. So I think there is a limit somewhere. I have no idea what it is, but I've never needed to store that many arrays and arrays to know. But yeah, if we print this out, it'll just give us all of the different arrays combined. They're useful over having any other type of like sort of like a number, for example, because, well, you store multiple elements in it and you can kind of use them as a running memory. So you can take information that you have, add it to the end, remove it from the end, sort of do little lookups on it. So we can use this .append function. So you take the variable name, you say .append, and you give something inside of it, and it will will take your array and add a number to it. We can also add, access these things that we've added. So if we define an array like this, and we print out the 0th element, we'll get 6. And I guess I'll quickly pause. What would happen if I asked for the 2nd element of the array? Which number would I get? You would get the 18, and that's because, yeah, Python is 0-based index, so I guess you just count 0, 1, 2. So the second one is 18. And then why do I have this block? I guess it's exactly for that. Who knows? Yeah. You can also slice an array. Essentially, it's like taking a piece of bread and you just slice it in the middle, and then you have 2 different pieces of array, so to speak. You can remove the last element using pop. So myArray.pop takes whatever's at the end, removes it. You can also remove a specific index. So if you give index 2 to pop, it will take 18 and it'll make 18 no longer part of it. And a little fun fact about pop is that it actually extracts the value too. So if you assign a variable to whatever this returns, you'll get the array and also the value that you took out of it. Cool. So hopefully that was, I guess, once again, super boring. Introductory, sort of getting everything up to speed. I feel like I probably went a little bit too in-depth with that, but that's all right. Do we have any questions about kind of that starting bit?
So arrays will be the same as lists?
Yes.
Yeah?
Oh, yes. I'm sorry about that. I should have clarified. Within Python, they're called lists, but in pretty much every other programming language, they're called arrays. It's the same thing, yeah, just a different word. Yeah, no worries. So, I mean, yeah, especially if you're like Googling stuff, searching like list will usually bring up Python results.
List.
Yeah, so when you slice a list, does it include the 2 specified indexes?
That's a good question. I believe it includes one of the indexes, but it cuts off at the end one. I guess we can see. So we go from 2 to 5. It looks like it wasn't inclusive of all of them, actually, sorry. So if we go from 2 to 4, 18. Oh, yeah. So I don't know why that wasn't giving me an error. 5 is not an index in this array because it's 0-based index. So yeah, it includes the first one, but it doesn't include the second one, or the last one. That was a good question, thank you. Cool. Do you guys want to do this little exercise? Sure. So we have some variables, some arrays. Basically, you should be able to get through all this by just copying and pasting some stuff above. guess I'll give you all about a minute or two to go through. Do we want to quickly go through a solution now? Sweet. So pretty straightforward for the first one. We just have, I guess, the challenge of adding element to the end of the array. So we can do that with our append function. So we can say array, which is our variable name, dot append, and put element inside of the round brackets. And if we run this, we'll see our array, element added to the end, array. And then our next challenge is to remove the 0th index. So we can say array.pop, and then put 0 inside of there. So if we run it again and print the array, we'll see we've taken the 5 out of it. And finally, we want to print the 3rd index. So we can say print, just as above, and then array sub. So I guess you'll hear that pronounced sub. It's just the square brackets you're indexing into it. Array sub, and it was the 3rd index, 4th element, so sub 3. And we'll print out 9, which is, I guess, the 4th, but also the last. Little fun fact, can be useful sometimes if you need to access the last one. If you ask for the negative 1st index, so like this is 0, this is negative 1, Python, unless they've updated it, Python lets you overflow to the back, so negative 1 is the last, negative 2 should be 7. It's a little bit weird, but it lets you do it. Sweet. I guess by show of hands, how many of you are familiar with dictionaries? A little bit. Cool. So I guess we can talk about it a little bit. So you can think of dictionaries sort of like a, well, I guess not even sort of. You can think of them like an unordered list. They are a list that just doesn't have some sort of organization to them. So instead of indexing into the list using 0, 1, 2, 3, you would index into it with different keys. So these are just different strings or different names that you give each of the variables. So we can create a dictionary here, and it's defined similar to a list. Instead of square brackets, you give it curly brackets. And we can just as much define an empty dictionary. It'll let us do that, no problem. But then we can start defining different objects in it. So we can say store this at I guess later on I have an example for this. So I'll say eclipse. And you define it by saying here's a string, give it a colon, and then sort of what the value is. So I think the idea behind this one would just say car models and who made the car. So Eclipse was made by Mitsubishi, and we follow that with a comma. So this is kind of the format of your dictionary. If I go ahead and run this, you'll see that it's stored. I've now stored this information, which is fine. We can store pretty much the same thing. If this was our entire goal, we can store this information with just like an array. But where this becomes useful is if we just want to start like indexing into it. So if I go ahead and run this block, I can say my dictionary, what's the value held at the key eclipse. This is your key, the value is Mitsubishi, so we get Mitsubishi. You can start thinking of how this could be useful if you have, like, say this is a database of all of these different car manufacturers and models. So say we had like the F-150, and that's made by Ford, and we had like, ooh, cars. What cars exist? What's your favorite kind of car?
Toyota.
Which, sorry?
Toyota. Or what? Car?
Yeah.
I don't know.
Let's say Honda Civic, yes. Culture. So we can say Civic, and that's made by Honda. And we just follow that with that too. So now we can save that. We have this kind of mess. It's a little bit of a nightmare to look at, just printing it out, but then we can start doing more useful things. So you can imagine if you have like this application where you have like a list of cars and like a search bar. In your search bar, you just feed it into a dictionary. So like if I wanted to say like, you know, we only have a sample size of 3, so we're not searching a whole lot of stuff. But if I wanted to know like, oh, who made the Civic, I can run this code block and it'll look up and say, oh, Honda made it. So it's kind of, I guess, one example of how it could be useful. But there's a ton of different places. As well, for anyone who's done JavaScript, this is essentially a JSON object, which I guess is a little bit redundant because JSON stands for JavaScript Object Notation, so calling it a JSON anyway, it's kind of like that. So we have a little exercise here as well. I guess we can go into this. How much time do we have? A little bit of time. So I suppose using this, we're kind of combine the arrays part and the dictionaries part into one piece. So here we have an array with a couple different names and a database of a bunch of different phone numbers. Our sort of task here, I guess, is to use the array to index or use the third person in the array, index equals 2, to find their phone number. So we essentially just want to print out that. Does that make sense? I feel like I explained that in a bad way, but cool. I'll give you all about 30 seconds, and I'll take a sip of my water. All right, so I guess I'll go through model solution. So with problems like this, I like to try and think backwards. So at the end, we want the phone number. So how do we get the phone number? We have to look up in the array. So we'll have to take the numbers dictionary and try and find someone's name in it. How do we get their name? That's going to be from the people array. So somehow we're going to figure out which person we're looking for, but the name that we're looking for is from the people array, so we can say numbers sub people, and then sub, and we want to find the third person in the array, so index 2. So we want to find the second person. So what this is going to do, we go 2, 1, 2, we're going to find Bill, and then when that returns Bill, we'll be searching the dictionary using a string. Bill is going to find this number. So theoretically, if we print this out, Shift Enter to run, we will get the phone number for Bill. Awesome. So that's a pretty decent breakpoint between the sort of different portions of this workshop. Does anyone have any questions about sort of anything we've covered? Data types, arrays, dictionaries? Sick. Yeah, perfect. So I guess we'll carry on a little bit with some built-in functions. So functions in programming a lot of programming is pretty similar to math, which on one hand is nice because then it's like well-defined, but on other hands it's not super nice because I don't love math all the time. But this is one place where it is pretty nice. A function in programming is built exactly the same way as you would have, at least at a high level, the same way that you would have math functions. So you can think of all the way back to like, y is equal to f of x. X is your input, and oops, don't let me do that. X is your input, and you'll put it into your function. It'll do something. It'll do some magic. Maybe it'll square it. It's a super boring function, but you can do that. And it'll give you some output y. So I'll make a really quick distinction between operators and functions. So earlier we covered operators. These are, I guess, some built-in operators, plus, minus, multiply, divide. This one I believe is integer divide. I actually don't remember, squaring, modulus. Those ones are operators. They take two different things and do one operation. Function is sort of like a big brother version of that. You can take some input, and it can be whatever data type, it can be whatever information. You can do a bunch of lines of code to it, and you can return whatever. In fact, you can even return nothing. There's some cases where that's useful, but so Python comes with a couple built-in functions. One that we've used a ton is the print function. So essentially what this does is it takes whatever thing you give it, converts it into a string, and puts it into the console where you can see it. So you can run this. That's not going to be super. It's going to print hello world because we asked it to. But another useful function is input. So say you're going to try and write a command line interface, or CLI. It's a type of program where you don't have a graphical user interface. You just kind of like achieve what you need to achieve by like typing to the computer. Input is kind of like the way that you can talk back to the computer, so to speak. So we can say that x is equal to input, and what that's going to do is give us a place to type. So we'll maybe type something. I'll type whatever I want into this box, and it will assign exactly the string whatever I want to this, and I can print it out. One thing to note with the input, I guess if you're going to use it, since we're defining Python as dynamically typed, it assumes the data type that you're working with. If whatever I type in is going to be assumed to be a string, even if I type in something that isn't necessarily a string. So if I go ahead and run this again and type like 6, for example, I guess it'll still say 6 because you can store 6 as a string. But if I go on to say like try and add 5 to 6, and I define 5 as an actual number, it won't. You might run into problems there. So input always gives you back a string. So you might need to do some typecasting to solve that problem. And I believe we actually talk about typecasting in like 2 code blocks here. Input's kind of fun. You can give it a string inside of the input, and that'll act as like your prompt. So like, what is your name, Cameron? Hello. Little example. Another one kind of stolen straight from math is like your absolute value. So if we have -7, get the absolute value of it. Does nothing too surprising, just kind of gives you back 7. And yes, typecasting. So back in the first little bit, we talked about the different types. You can have a string, you can have an integer, you can have a floating point number. And what you can do sometimes is, well, certain pieces of information can be stored as different data types. So as sort of described above, you can have like a 7 stored as a string. And if you say like x plus 5, it should give me an error because it's like, I don't know how to add an integer and a string together. This doesn't make sense, which I guess it doesn't really. So what you can do is use the built-in functions for typecasting. It's called an integer. So you just take whatever x is, put it into the int function, and then it will understand and try and be smart about computing it like an integer. If you try and like jam something that is very much not an integer into the typecasting function, that'll complain. So you just need to be careful about like the different pretty cool built-in functions like min and max. So you can find the minimum value of an array, you can find the max value of an array. So you can even sort them. So if we have our array in some order and we want to sort it, we can do that. I believe if you want to sort in reverse, do I have that there? No, I don't. So if you want to sort it in reverse, let's try something. We're going off script today. You can say reverse equals true. Is it like that? Oh no, I'm unsure now. Oh, that's what I get for going off script. Is it like this? Yes, okay, I spent too much time in JavaScript. So if we say reverse, it'll sort it instead of in ascending order, descending order. This is what's known as an argument. We'll talk about that actually in the next code block with our user-defined functions. So with all of these functions, we've basically just used stuff that is already built into Python. But functions get really cool where you can start defining them yourself. So that's where, I guess, we have user-defined functions. So what we can do with a user-defined function is essentially take a big complicated piece of information, maybe a big code block, and simplify all of that into something that we can just call later somewhere else in our program. So say, for example, I just really often use this whole like square plus 2. We take a number, we square it, and we add 2 to the end. That's kind of a oddly specific thing. You're probably never going to make a function like this, but relatively simple. You can define a function to simplify doing that later in the program. So to the syntax for defining it, you have define, so def, follow that with a square, a space, sorry, and then you can name your function. You can name it whatever you want. I don't think you're allowed to have functions that start with a number. It has to be a letter. So square, I'll just press Command Z. Square plus 2. Otherwise, yeah, no spaces, can't start with a number, but other than that, you have pretty much total freedom in naming this thing. And then this x right here, this is what's called an argument. So that's what you're going to input to the function. Maybe this is going too in-depth, but I know this is something that confused me for like literal months. So the way that x is being defined here is sort of implicitly. So you can kind of think like we have x being fed to us and say like x is equal to 7. You can imagine that all of these variables up here are just being defined as any normal variable, except instead of being defined here, they're just defined wherever you call the function. So I'll go ahead and run this block so that it defines it. And then we can use it by, well, just calling it just like any other function. So if I feed 2 into it, if I give 2 as one of the arguments, it will essentially say like x is equal to 2, and then it'll say x times x, 4 plus 2, 6. Hooray. We can give like some other absurd number like 10, which I guess 102. You can also use functions to do other kind of crazy things. So like say we have some ASCII art that we want to print out. Once again, I don't know when you're ever going to do this, but for sake of example, you can define a function called printMac, and you can run that function and it'll go ahead and print out the thing for you. And then wherever else in your program, so for example, if I wanted to come down here and say like print, no, not in there. I'm not allowed to print that out. Print Mac. Go ahead and run this and it'll give us the thing here too. Was the doorbell downstairs? Hopefully. So there's user-defined functions. That was a little bit quick, but I guess any questions? Uncertainties, queries? Fantastic. We're breezing through this. So yeah, Booleans. They're another data type. Surprise, there's more. There's a decent bit more, but I guess we're just kind of going through. Boolean is a really simple data type. You can kind of think of it, you know, computers are all ones and zeros, and well, so is a Boolean. You have true or false. One thing to note with Python is that this was the trick that caught me up a little bit earlier. In Python, true and false are capitalized. If you have lowercase false, then it thinks it's a variable. But uppercase false thinks this is a Boolean, so you can set a variable here and print it out. It's false. You can do cool things with it though. So you have Boolean operators. So you can sort of ask questions like, is 1 equal to 2? So this is more along the lines of like what you expect in like math when you're saying like, 2 is equal to 1 plus 1. Is sort of like a statement that is true. A single equals is assignment, so you're taking the variable, or you're taking a value, assigning it to a variable. Double equals is asking a question. So here we can kind of say like, is 1 equal to 2? No, the answer is no. We can say like, is 1 less than 2? Yes, that kind of stuff. Is 1 not equal to 2? So you can have sort of this inverse operation. Yes, 1 is not equal to 2. Pretty straightforward. You can start chaining them together, and you can even use the Boolean operators of and or, and also not, where you can sort of take, what is true and true is true, true and false. These different operators, I guess, really quickly, and or, you can and things together. So like, and is only going to return true if both of your inputs are true, or will return true if either of the inputs are true, but not if they're false, and not just inverts it. So have that, and then you can really start chaining stuff together. This takes like a solid 30 seconds to parse through when you're like reading it, but yeah, you can start doing stuff like that. So I'll maybe jump over or skip over this bit just in the interest of time, but Booleans are, like everything else in Python, Python assumes what you're working with, so like it'll automatically cast stuff, and it's convenient 99% of the time, but it can be really confusing if you start running into problems. So this is there. If you ever have problems with like Booleans not working the way you expect them to, you can reference that part of the slide, but there's that. So all of this true and false, it's pretty straightforward, but where it gets interesting is where you can start using it to do conditional logic. So you have an if statement, which kind of is where you can start really making a useful program. So say we have a variable and our value, we have it just equal to true. We can say if true and print something inside of it. The syntax of this is usually most code editors will just kind of automatically indent after you type an if statement. So syntax of it is just if followed by some round brackets and a colon, and then you'll have a new line with indented by tab. You can go ahead and run this. Since our value is true, it will run whatever code we have indented. Conversely, if our value is false, it will do nothing because our code is indented behind a false if statement, so it won't run that bit. I guess on the topic of implicit type conversions, if we say value is equal to 1, value will be stored as an integer, but it will still run through because 1 is considered to be true. It makes sense, but it can definitely be confusing if you're expecting it to behave like a number and it's behaving like a Boolean. Further, we can use logic equations. So for example, if we say like compare x to different values, we can say like x is equal to maybe 6, and we'll see there's 3 print statements below, but we're only going to output one of them. So like, oh boy, that's a small number. That comes from x being less than 10. Or if we have like a really big number, x is greater than 10. We can do different things based on different values. I'll skip this one because that's no longer true. Python had an update. And yeah, we can have a little bit more control over our program flow if we use if and elif, or elif and else. So the sort of structure that we have for this piece is like saying, okay, if x is this value, run the code inside of it. Elif is kind of like shorthand for else if. So we can compare it to another conditional. So if, for example, this is not true, then we'll try executing this one and check it against another condition. And then else is kind of like a finally, like, okay, we've tried all of these different conditions. If nothing is true, then we'll go through this code path. So if I say sup, it'll say, false. It won't execute this, but, x is equal to sup. So it'll kind of stop here, and then it'll go through and run whatever code is inside of this. So in this case, it's that. If I, completely break the script and just give in, something that doesn't make sense, it'll say like, okay, whatever the heck this is not hello, so we're not going to run this one. Whatever that is, it's not sup, so we're not going to run that one. And oh no, we've gone through all of our options, but we still got to run something, so we'll say else and print out that one. I'll skip over this because it's kind of a little tedious. And yeah, a little bit of an exercise. This one's a little bit of fun, but not a ton, so I'll just go through the solution. We can define a function called greet. So this is combining conditional logic, the Booleans, and function definition into kind of one little problem. We can define a function, and inside of this, we will sort of conditionally say different things based on, or we'll say hello to someone differently based on their age. So we can define a function called greet, input our name and age, and we can kind of abstract away the whole, like, how are we going to get name and age? We'll just pretend that we already have this information. We can have that given as a string, compare it. So we'll convert it to an integer. We can say, like, if age is less than 18, which is one of them. We can follow that with a new line and say return, because we're doing a function, return sup. And we can go back and use our operator and add name. So use our input variable here, and we'll return that. And why is this giving me a, why are you complaining? I guess we'll see when we get to concerning, but carrying on, we can say elif age is greater than 60. We can return, what is it, hello, plus name. And otherwise, if someone is not under 18 or over 60, they must be in between them. But instead of writing out the whole like in between, we can just say, okay, neither of those worked. Let's go ahead and return hi plus name. And here we are actually going to use the function. So we define an input, assign those to those variables, and then we just feed in the variables to the function that we defined above. So if I go ahead and run this, what is your name? Cameron. How old are you? Some number. And 78, I ended up being 78, which was over 60, so it was polite and used the full word. Yeah. Double check on our time here. I think we're nearly out of time, or like super over time. Yeah, nearly out of time. But maybe I'll go through loops, and that's pretty much the end of it, actually. So should have no problems. So loops. Conditional logic is like the majority of like how you can use sort of like a computer to write a non-trivial sort of function, something a little bit more impressive than you can just do with a calculator. So a while loop kind of extends that a little bit. So you can think if we wanted to have, I actually kind of like this intro of a while loop. Might be a decent way to think about it. So suppose you wanted the user to input something, and you wanted to make sure that they were inputting something specific. Like, so say for example, if you had something that was using, like converting their input to be an integer, you want to make sure that their input is something that can be converted to an integer. So you want to validate it somehow. So what you can do is, for example, take some input and add an if statement to it. So like, in this example, we're just saying like, okay, did they input exactly what we asked them to? And if they didn't, well, we're going to ask them again until they actually give us what we asked them to. But if they actually did input what we asked them to, then do some useful thing. So instead of following the rules, I like to be a rule breaker. I'm going to like, input something else, and so far it's working exactly as we want it to. We've input something and it's asked us again. But if I continue breaking the rules, the program will just end and it'll not carry on. Like it doesn't matter. I can sort of do bad inputs twice and it'll, yeah, anyway. I hope that made a little bit of sense. Sort of worked, but problem is we asked second time and it just doesn't. So what we can do is slightly reframe the way that we've written this code so that we don't let it continue on until we've like gotten what we want. So first we take the user input exactly as above, and instead of saying if, we're going to say while and have the same condition in there. So what's going to happen is we're going to keep running everything inside of this loop until this condition is true. So if I type something that is not nat, Boolean operators, we say not equals to, that's going to be false if I don't type in exactly that. And this is going to keep, or sorry, that will evaluate to true, and this while loop will keep running this code until this is false. So we can go ahead and run this, and it doesn't matter how many times I type not nat, it will just keep asking me again and again until I do exactly as the while loop is expecting, and this statement becomes true, or this statement becomes false, and as soon as it becomes false, we carry on with the rest of the program. So that's one way we can sort of validate user input. So that's kind of one use of a loop, not a super useful one, but we can take that information and sort of transform it a little bit to get something super useful. So say you wanted to print out the numbers 1 through 10, kind of a silly thing, but happens a decent bit where you kind of need this sequence of numbers. So you can do it like this, but that's a lot of typing, and it's not super flexible. Like if I wanted to type out the numbers 1 to 100, I'm going to be here for a while. What we can do instead is have a while loop that just increments this number for us. So like we can say I is equal to 1, and while I is less than 10, so like our end value, we'll just keep printing it. And then right at the end here, we're using that like little shorthand, the increment bit. So we sort of take I, add 1 to it, and it'll just keep doing that, and we get the same 10. Now, if I wanted to print out to 100, I can just say that my end value is 100, go through, and I kind of instantly get the response I'm looking for, and saved a little bit of time in the meanwhile. Another little exercise, I'll just go through it. You can take advantage of this flexibility of the while loop. Say we wanted to, for some reason, once again, these are all useful in some contexts. They're kind of a ridiculous claim just to make in the middle of nowhere, but they are sometimes useful. Say we wanted to have a while loop that counts by 2s instead of 1s. So print 1, 3, 5, 7, 9 instead of like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can do that by just changing the amount that we increment it by. So now we'll take steps of 2. If we wanted to, print out 0 to 9 and take steps of 2, kind of like the even numbers, we can do that. Pretty useful. And that brings us to a for loop, which is a shorthand, once again, for doing a while loop. So we can say like for I in range 1 to 11, print I, and that will do the exact same thing as our while loop above. Essentially, your I is less than or equal to some value. That's going to be your endpoint. Whatever you define it to here is going to be your start point. And that's exactly what we're doing with the range here. So we have a start point, end point, and I believe range even allows us to have a step. So you have an optional third argument there where you can do your step size, but it's not often used. Essentially, it'll just run this piece of code. It'll replace I with a different number each time it goes through, and yeah. So our last little exercise here, we do still have a little bit of time, so I'll pose it as a question. Without running this, just kind of like go through in your minds and what will be printed out when we're done running it.
You print the numbers from 0 to 14 back in steps of 2?
Almost. So here instead, we don't have the print statement inside, so we're...
It will sum.
Yes. Yeah. Sorry, a little bit of a trick question. We shifted gears. So, yeah, I guess we're going through and we're summing. I'll be honest, I don't totally know what the answer will be, so I'll try and it'll give us a single number. So if we have 0, all right. I think it's going to be 28, but I'm not 100% sure. Oh, it's 30. Oh no, I was off by 1. But yeah, we went through, I guess I thought it went through 14 times, but I was wrong. It went through 15 times and gave us 30 because it added, I guess, 2 to itself 15 times. Cool. That's all I have. We have a couple minutes for questions if you want. They can be about the workshop. They can also just be about anything coding related to. If you, yeah.
So, well, I know that you will say like, to learn we need to practice and practice and practice. Is there like a website that you recommend, or
Yeah,
like
actually.
HackerRank, or is there something there better?
That's a wonderful question. So yeah, there is a website. If you go to, there's a handful of different types of sites, but I like LeetCode. So LeetCode.com. And on this website, I guess this is not a super great homepage in my opinion, but you can go to problems, and it'll essentially give you a bunch of problems, I guess similar to the ones like, what one here? Similar to this one. So like it'll give you some definition where it's like, I want these things to happen if I give this input, or like usually it frames it as like a really fun question, like, you know, if an egg can survive a fall of like this distance, based on something like what's the highest that I can drop from given these conditions or whatever. They're usually kind of like these fun little problems, and it'll give you the problem and you can write some code and run the code against a bunch of test cases and see if it indeed solves the problem. So yeah, I would recommend LeetCode. It's a great place to practice.
What was the website?
LeetCode.
LeetCode?
Yes. I'll put it in some slightly bigger text because my screen size is like way too small.
Oh, Leet. Oh, yes, I got it. Yeah, because there is no other way we need to practice and practice.
Yeah, exactly. Like, definitely, like learning comes from practicing, but it's really hard to just sit down and say like, I'm gonna do code and not have like something to work on. So. And I don't know, they might block this behind like premium, but even if you search like different LeetCode problems, like on YouTube, you can probably find like walkthroughs and solutions. Like if you ever do get stuck, and it's just like, why isn't this working? Then usually there's a walkthrough to help point out like, hey, maybe this would have been, you know, here's the key piece. Yeah. Any other questions? Cool. Well, thank you all for joining this workshop. I hope that it was insightful in some way. If you do have any programming questions, you can reach out to me on the natHACKS Discord. Cameron should pull me up.
Thank you very much.
Yeah, no worries.